Here's a video on given the zeros of the function. They're a little bit more difficult, and we want to write the polynomial function equation. So I want to review with you for a minute. If I give you a zero like 2 plus 5i, it's a complex zero. So complex zeros occur in pairs. So we want to come up with the conjugate. The conjugate of 2 plus 5i, remember you change the imaginary piece. So that's going to be 2 minus 5i. So you're going to have then two zeros, 2 plus 5i and 2 minus 5i. Also the case when you have radicals, square roots. Square roots also occur in pairs. So here's a second example. If we give you 1 plus 2i, you again change that sign, and you're going to have another one at 1 minus the square root of 2. So they also occur together. You're just changing the sign in front of the radical or the imaginary part. All right, let's move on to an example. If we give you 3 plus 2i as a 0, then you'll have another one at 3 minus 2i. Now we want to go ahead and write down what is the equation for this in factored form. So f of x equals, and now we write it in factored form, you have to think opposite, x minus 3 plus 2i and x minus 3 minus 2i. All right, so what we have here is in factored form. What we want to do is we want to FOIL it out. So what I'm going to do first is I'm going to just distribute the negatives through here. So here's what it's going to look like. F of x equals x minus 3 minus 2i. Again, just distributing the negative through and dropping those parentheses. And then x minus 3 plus 2i. Now I'm going to regroup. I'm going to group the first two terms together, and then FOIL. The one nice thing about foiling with conjugates, or with complex conjugates, is they cancel out. So we can do this thing called the cheater FOIL. And you only have to worry about the first and the last, because the middle ones cancel out. So you only have to take care of those two and these two. This is only acceptable when you have your conjugates. So just see what it looks like. I'm going to take x minus 3 and x minus 3 and multiply them together. So it's x minus 3, x minus 3. Then I'm going to take the negative 2i and the plus 2i. So negative 2i and positive 2i. So I'm only doing first and last. All right, now let's continue on. I'm going to FOIL these two together. So we get x squared minus 3x plus 9. And this becomes negative 2i times positive 2i is negative 4i squared. Now we'll continue on. These are my like terms. So I get x squared minus 6x plus 9. And then do you remember what happens with an I squared? It replaces with a negative 1. Now these are alike again. This becomes a positive 4. Now we combine that. X squared minus 6x. 9 plus 4 is 13. So there is our function in standard form. All right. Last example in this video, we have a fourth degree polynomial. We give you a 0 at negative 1, another one at negative 1, and then 3i. Notice that this is a complex 0. So since you have 4 zeros, you must have a fourth degree polynomial. If you have a 3i, then you must have another zero at, remember, its conjugate, negative 3i. So the next step is to go ahead and write those all in factored form. So you think opposite. So opposite would be x plus 1. Opposite would be x plus 1. Opposite would be x minus 3i. Opposite would be x plus 3i. Now what we have to do is we have to FOIL this all out. So it's a good idea to FOIL things that look alike. So I'm going to FOIL these two things together. And I'm going to FOIL these two things together. So let's take care of the blue. So first, outside, inside, last. Then we go to the purple. Now, we get to save a little time on the purple because we get to do cheater FOIL. Only first and last. First, last. We don't care about the O and the I because of those are being conjugates. So negative 3i, positive 3i is negative 9i squared. All right, now let's clean up the blue. We got like terms with 1x and 1x becomes 2x. In the purple, we have an I squared. What happens to an I squared? It becomes a negative 1. All right, we're getting there. Now we have to continue multiplying. So, I'm leaving the blue one alone, and I'm just going to clean up the purple one. Negative 9, negative 1 becomes a positive 9. Now to combine this into a fourth degree polynomial, I have to take everything in the blue in terms and multiply it to everything in the purple. So x times x, x to the fourth. X times 9, 9x squared. 2x times x squared, 2x cubed. 2x times 9, 18x. Last one, 1 times x squared, and 1 times 9. So we've now distributed everything in the blue to everything in the purple. Now we clean it up. We put it in standard form, combine any like terms. So x to the fourth is left alone. My next highest term is 2x cubed. These two terms are alike, so they become positive 10x squared. But this is by itself, 18x, and then that's by itself, plus 9. And we are done.